For question 26, the question reads, David put a paper cup into a glass beaker as shown in the diagram below. He glued a magnet to the bottom of the cup. He glued with another magnet to the bottom of the glass beaker. So in this diagram setup, we can see that the paper cup is over here. There's a magnet on top, or rather in the paper cup, on top of this glass beaker with another magnet below, directly below the paper cup. Now, the question reads, for part A, David observed that the two magnets repel. What does this tell you about the poles of the magnet? So the answer is the like poles of the magnet repel each other. Like poles of the magnet repel each other. Part B. Name the two forces that are acting on the paper cup to keep it in this position. So in other words, the magnetic force of repulsion is acting between the two magnets, and what's keeping it in position is actually the gravitational force downwards that's acting on both objects as well. So the two forces that are acting on the paper cups to keep it in this position is gravity or gravitational force, and the magnetic force of repulsion. So that's the answer for part A and B. For part B, let's read the question. David added 10 grams of aluminium thumbtacks into the paper cup. This caused the paper cup to move down a little as shown in the diagram. So you can see that there are thumbtacks added. So the mass of the thumbtacks actually exerts a downward force due to the pull of gravity. And you notice there's a distance between the magnet on top and the magnet below. So this is the distance between the two magnets. Next, let's read. He continued to add more aluminium thumbtacks into the paper cup, and he plotted a graph to show how the mass of the thumbtacks affected the distance the paper cup moves. So in other words, the change variable is the mass of thumbtacks that was added and the distance of the paper cup moved down is the result. That's recorded. Hence, he plotted the diagram as shown below here. So we can see that it is actually a curve starting from mass 0 load grams. And as we add more and more mass to the paper cups, what happened is that the distance moved down by the cup increases as the amount of thumbtacks increase in the paper cup, and it reaches a height, or rather a distance, moved down at about 4.8 millimeters. So the question asks us, why did the graph stay constant with mass greater than 40 grams? So we can see at about 40 grams, there's a flat line of 4.8 milliliters. So what is the reason behind it? The reason is that the paper cup on top touches the paper cup below. So that's the reason why there's no increase in the distance moved downwards by the paper cup on top. For part D, the question reads, David removed the aluminium thumbtacks and added 10 grams of iron nails into the cup. The paper cup moved down more than 10 grams of iron nails than of 10 grams of aluminium thumbtacks. Explain the above observation. So you can see from the diagram, at 10 grams of aluminium tag, the distance paper cup moved down was 3.8 millimeters. But if we added instead and replace it with 10 grams of iron nail, the distance moved down by the paper cup was actually more. So in other words, if we were to plot the graph, it will look something like this, going upwards. So what was the reason for the paper cup to move more if they were replaced with 10 grams of iron nails? So because due to the force of attraction by the magnet, and iron is a magnetic material, whereas aluminium is not. So in other words, the reason for the paper cup to move downwards more is because iron is a magnetic material, whereas aluminium is not. So the reason why it was pulled downwards, the paper cup, was due to the fact that the iron nails were attracted by the magnet. And that's the answer for part D.